Hello, Mr. Luong. This is Morella Trin in AP Physics C Period 1. This is my take-home FRQ number 3, Part 2, covering letters E through G of the FRQ. Starting with letter E, it's asking us to derive the function for the maximum speed of the system in terms of R, G, mu s, and theta. We can start with the function net force y equals 0. It's not moving up or down at all. We can break the total forces in the y direction up to be Fny minus Fsy minus mg, all equal to 0. Then we can break this up into its component parts. Fny is going to be Fn sine theta. Your static friction in the y direction is going to be mu s Fn times cosine theta, and then mg is f of g, which equals 0. We can pull out the Fn from these two terms, which will be multiplied by sine theta minus mu s cosine theta, and then move over the force of gravity, mg. Isolate for Fn by dividing the function, this function here. You get f of n is equal to mg over sine theta minus mu s cosine theta. And then we can also use the function net force in the x direction is equal to max to help solve this. We can break up the net forces in the x direction into Fn x plus Fs x, which is equal to mac, because the only acceleration in the system will still be your centripetal acceleration. We can break all of these up into their component forms. Fn cosine theta is equal to Fnx plus Fs, which is mu s Fn times sine theta, to put it in the x direction, is equal to mv squared over r. We can again pull out the common variable of Fn times cosine theta plus mu s sine theta, all equal to mv squared over r. And we can again isolate for Fn. Fn is equal to mv squared over r times cosine theta plus mu s sine theta. We can then set both Fn equations equal to each other. Mg over sine theta minus mu s cosine theta is equal to mv squared over r times cosine theta plus mu s sine theta. We can cancel out the m's, which appear on both sides, and isolate for v squared by multiplying this entire denominator up here. We get rg times cosine theta plus mu s sine theta all over sine theta minus mu s cosine theta is equal to v squared. And then isolate the v by square rooting it. V is equal to the square root rg times cosine theta plus mu s sine theta all over sine theta minus mu s cosine theta. And then for part F, we gotta start by explaining why this is your maximum velocity. We can do that by drawing the free body diagram for it. This is your Fn, this is your F static, and this is your F of gravity. This is your maximum velocity because it is happening when F of S is stopping your object from moving up along the surface of the cone. The faster it goes, the more likely it is to stray upwards. So F of S is just barely enough to stop it from starting to go upwards. So for letter F, it's asking us to find the equation for the minimum acceleration or the minimum velocity of the problem. The free body diagram would look like this. Well, F and FG remain the same. F of S is now pulling upwards, stopping the block from straying downwards because it's just barely fast enough to stay in the same place, right? If it were any slower, it would start going down, and Fs is counteracting that movement. So we can use the same equations as before. Net force, the y direction is equal to 0, 0. And this changes by, when we break the net forces up, we get Fn y, this time plus Fsy, because they're acting in the same y directions. All minus mg is equal to 0. We can break all these up the same way. Fn times sine theta, but this time plus mu s cosine theta. It's the same parts as the last problem, so there's no need to repeat work. It's equal to mg. We can isolate for Fn by dividing this term again. Fn will be equal to mg over sine theta plus mu s cosine theta. And then the net force in the x direction again is going to be equal to your centripetal acceleration, mv squared, over r, this time when you break it up, because they're in opposing x directions, you get the equations, the parts of the equations, Fn cosine theta minus, this time, mu s Fn sine theta is equal to mv squared over r. You can pull out the Fn and divide. We've done this already. Fn will be equal to mv squared over r times cosine theta minus mu s sine theta. We can set these equal to each other again. mg over sine theta plus mu s cosine theta set equal to mv squared over r times cosine theta minus mu s sine theta. Cancel out the m's and isolate for v squared. We get rg times cosine theta minus mu s sine theta all over sine theta plus mu s cosine theta equals v squared. Square root both sides. Again, rg times this whole term, cosine theta minus mu s sine theta over sine theta plus mu s cosine theta. The only thing that switches between letters F and E is the directions of your static friction, because one is pointing up along the plane of movement and the other is pointing down. Finally, we have letter G asking us to prove that the net force of a given function, the F net, is equal to cotangent theta plus mu s over 1 minus mu s cotangent theta. That's a spider. Sorry. Continuing on from the spider issue, it's this whole term times mass times gravity. We can start this by stating that the net force is equal to your centripetal force. We showed that in previous problems, not explicitly, but we know that net force in the y direction is equal to 0. The parts balance out, and the net force in the x direction is equal to MAC or F of C. So net force, F net force, they're the same thing, is equal to F of C. We can break up F of C into parts. mv squared over r, and then we can solve for v squared by using part b. V squared is equal to rg times cosine theta plus mu sine theta over sine theta minus mu cosine theta. So let's plug that in. Net force is equal to m over r times your v squared, which is equal to rg times cosine theta plus mu s sine theta all over sine theta minus mu s cosine theta. And then we can cancel out the r's to get mg times cosine theta plus mu s sine theta all over sine theta minus mu s cosine theta. And then to get it to look like this, we can simplify our trigonometric functions by multiplying by 1 over sine theta over 1 over sine theta. this is equal to 1, so it won't actually change the contents of the problem. It'll just make it neater when you simplify. And distributing this to all the terms in the parentheses, we know that cosine theta over sine theta is equal to cotangent theta, so we can plug that into here, and then sine theta over sine theta will just equal 1. So we get cotangent theta plus mu s theta, mu s, not mu s theta, all over 1 minus mu s cotangent theta, which is the same thing as